All right, let's solve some proportions and their applications. Okay, so this says that a proportion is an equation of the form A over B equals C over D. You cannot let B or D, so the denominators, you cannot let those equal 0. And it states that two ratios or rates are equal. So on part A here, where it says 3 is to 7 as 15 is to 35, so we want to see if those are equal. And so, well, they want us to write it as a proportion. So to write it as a proportion, we're going to write it like this. 3 is to 7 as 15 is to 35. And if you'll notice, they are equal to each other. If you multiply 3 by 5, you get 15. If you multiply 7 by 5, you get 35. So those are equal to each other. They are proportions. So in part B, it says 5 hits in 8 at-bats is the same as 30 hits in 48 at-bats. This is a baseball reference for you non-sports people. So this says 5 is to 8 as 30 is to 48. That's how you write that as a proportion. So we're going to look at the last one. $1.50 for 6 ounces is equivalent to $2.25 for 9 ounces. So $1.50 for 6 ounces is equivalent to $2.25 for 9 ounces. Now, if you need to determine if something is a proportion, what you do is you look at the cross products. Cross products means you multiply the denominator of one times the numerator of the other, denominator of one times the numerator of the other, and you see if those products are equal. If they're equal, then it is a proportion. If they're not equal, it is not a proportion. So let's look at part A here. 4 is to 9 as 12 is to 28. So here's how you check it. You want to do the cross product, 28 times 4. Whenever you multiply that, you get 112. So I'm going to write this 112 above that 4. Whenever I multiply 9 times 12, I get 108. Those are not equal, so part A, not a proportion. Okay, so let's look at part B. 17.5 is to 37.5 as 7 is to 15. Well, in order to check this, we have to cross multiply. 15 times 17.5, again, I'm using my calculator, 15 times 7.5 is 262.5. Now I'm going to multiply 37.5 times 7. And I get 262.5. Because those are equal to each other, this is a proportion. Okay, so whenever you have a problem like this, where you have a variable and you're solving for the variable, again, we're going to use cross products. So you multiply the denominator of that one times the numerator of the other one, denominator of this one times the numerator of the other one. So I get x times 7 is equal to 63 times 4. So now I'm going to write this properly. X times 7 is 7x. 63 times 4 is 252. So now in order to solve for x, I'm going to divide by the number in front of the variable. So I get that x is equal to 36. Now, can I check my work? Absolutely. So over here off to the side, I'm going to check this. 36 over 63, is that equal to 4/7? Do your cross product and check it and see. 7 times 36 is 252. 63 times 4 is 252. Those are equal, so I know that I have the correct answer here. All right, everybody, let's solve proportions and their applications. Okay, so this page just tells you that a proportion is an equation that looks like a fraction equals a fraction. And whenever you read it, you would say the numerator is to the denominator as the numerator is to the denominator. So on part A down here, it says 3 is to 7 as 15 is to 35. So in order to write that as a proportion, you would do this. 3 is to 7 as 15 is to 35. So that is that sentence written as a proportion. Okay, so let's look at part B. 5 hits in 8 at-bats is the same as 30 hits in 48 at-bats. So you would write that as 5 is to 8 as 30 is to 48. And I'm not going to talk about whether or not they're equal just yet. We'll get to that on the next page. So the next one says $1.50 for 6 ounces. So $1.50 for 6 ounces is equivalent to $2.25 for 9 ounces. Okay, this page says that in order to determine if an equation is a proportion, you simply cross-multiply and you compare your cross products. So in part A, I've got 4 is to 9 as 12 is to 28. And we want to know if those are equal to each other. There are several ways to do this, but one of the ways that I really want you to get used to is looking at the cross product. And so you multiply 4 times 28 and 9 times 12, and you see if those are equal to each other. 4 times 28 is 112, and 9 times 12 is 108. Since those are not equal to each other, drew the line through the equal sign, then I would say that they are not a proportion. You could just say no. No would be fine. Okay, so let's take a look at B. 17.5 over 37.5, or 17.5 is to 37.5 as 7 is to 15. Well, let's do the cross product and see if those are equal to each other. So I would do 17.5 times 15 and see if it's equal to 37.5 times 7. So I'm going to grab my calculator and I'm going to type this in. 17.5 times 15, and I get 262.5. And I'm going to type in 37.5 times 7, and I also get 262.5. Those are equal to each other, so I would say yes on part B. Okay, so understanding that cross products are equal to each other helps you solve equations that are set up like proportions. So in this one, if I'm going to solve for x, I can cross multiply. So I've got 7 times x, and that is equal to 4 times 63. So I get 7x is equal to, and I'm going to do 4 times 63 on my calculator, 252. Now you have to look at that and ask yourself, what do I do to solve for x? And I divide both sides by 7. 252 divided by 7 is 36. X is equal to 36. Now, if you want to check your answer, so off to the side, I can do 36 is to 63 as 4 is to 7. Cross multiply. 36 times 7 is 252. 63 times 4 is also 252. Those are equal to each other, so I am certain that 36 is my answer. Okay, this problem is done a lot like the last problem. So again, we're going to cross multiply 144 times 4 and A times 9. And it doesn't matter which one you put on the left or which one you put on the right. It really doesn't matter which order you go in. As long as you are cross multiplying, it does not matter which one comes first. So I would have 144 times 4 equals A times 9. So 144 times 4 is 576. And then I would divide both sides by 9. And I get that A is equal to 64. If you wrote it as 64 equals A, that is the same answer, so it doesn't really matter which way you write that. Now, can you check your work? Absolutely. 144 is to 64 as 9 is to 4. Cross multiply to check that. We already know that 144 times 4 is 576. So on my calculator, I'm going to type in 64 times 9. And I get 576. So I know that 64 is equal to A. Okay, so things don't really change when we have negative signs. You just have to use the rules that go along with negative numbers. So you're still cross-multiplying. 91 times negative 4 is equal to 52 times y. So on my calculator, 91 times negative 4 is negative 364. And to solve this, I divide both sides by 52. And I get that y is equal to negative 7. Check your work in the same way. So we're going to cross multiply. We already know that 91 times negative 4 is negative 364. So now I'm going to type in 52 times negative 7, and I get negative 364. And those are equal, so I know that negative 7 is my answer. Now the reason why we do proportions is for things like this. It's not always clear exactly what we need to do for a recipe, or in this case, for medication. And so we can set up a proportion to solve for something that maybe isn't exactly what's on the recommended dosage on the back of a bottle or something like that. So in this case, it says when pediatricians prescribe acetaminophen to children, they prescribe 5 milliliters of acetaminophen for every 25 pounds of the child's weight. If Zoe weighs 80 pounds, how many milliliters of acetaminophen will her doctor prescribe? So we're going to set up a proportion, and I always on these things use my units of measure when I write up the proportion. So I would put 5 milliliters over 25 pounds. And that is equal to, I don't know how many milliliters, because if I put milliliters on top on the left, I need to put milliliters on top on the right. I don't know how many milliliters over Zoe's weight, which is 80 pounds. And again, we can cross multiply. So 80 times 5 is 400. 25 times x is 25x. And you would divide both sides by 25. And you get that x is equal to 16. But what is it we're looking for here? Remember, we were looking for milliliters. So this means 16 milliliters. So Zoe would get 16 milliliters of acetaminophen. Okay, one brand of microwave popcorn has 120 calories per serving. A whole bag of this popcorn has 3.5 servings. How many calories are in a whole bag of this microwave popcorn? Now, there's several ways to work this problem, but I'm going to show you the way that we're talking about right now. So I'm going to show you the way using proportions. So 120 calories in one serving. And that's equal to, I don't know how many calories in 3.5 servings. So again, you can cross multiply. So I get that x is equal to 120 times 3.5. So 120 times 3.5 is 420. So what does 420 stand for? In this situation, it stands for calories. That's what we're looking for. 420 calories. Okay, so in this one, Josiah went to Mexico for spring break and changed $325 into Mexican pesos. At that time, the exchange rate had $1 US is equal to 12.54 Mexican pesos. How many Mexican pesos did he get for his trip? So we're going to set up the proportion. We know that $1 is equal to 12.54 pesos. And Josiah has $325, and I don't know how many pesos. So I'm going to cross multiply. X times 1 is X. 12.54 times 325. So on my calculator, 12.54 times 325 is 4,075.5. And in this case, always on word problems, you label your answer pesos. Okay, so take a look at this problem and it should look pretty familiar to you. We actually already learned how to do this type of problem, but there's another way to do it, and that is with proportions. Now, if you are comfortable with the other method, keep on using the other method, but you might want to take a look at this. I'm going to do the next several problems with the proportion method. Again, if you don't like that, I don't care if you never use the proportion method. But I am going to show it to you. So, this says the amount is to the base as the percent is to 100. Now, I'm going to simplify that just a little bit. I'm going to say that the word is over of is equal to percent over 100. So whenever you read these problems, there will be a number that's closer to the is, that'll be your is number. There will be a number that's closer to the of, that'll be your of number. And the number with the percent sign after it always goes over 100. Always. So, in this case, what number is, that's going to be my is. So what number is going to be x? This is my percent of 90 is my of. And according to this, is over of equals percent over 100. So I've got x over 90 is equal to 75 over 100. So again, to solve any proportion, you cross multiply. So I get 100, x is equal to 90 times 75. So on my calculator, 90 times 75. And I get 6,750 is equal to 100x. To solve this, I divide both sides by 100. So x is equal to 67.5. I'm not sure what happened to the rest of the answer or the solution here. I guess I got distracted and forgot to put it on the page. So you're just going to have to take my word for it on the last problem. Okay, for this problem, again, we're going to look for is over of equals percent over 100. 19 is, so there's my is. This is my percent of what number? So I'm going to have 19 in the is position, x in the of position, 25 over 100. So again, cross multiply. 25 times x is equal to 19 times 100 is 1900. Divide both sides by 25. And I get that x is equal to 76. Apparently I got distracted on every page. Again, you're going to have to take my word for it this time. Alright, this problem. What percent of 27 is 9? What percent is my percent? Now, if you'll notice, 27 is in between of and is. But if I say that the 27 is the is number, then what's going to be my of number? So really, you need to look at it backwards, I guess. Is my 9, of is 27. So again, is over of, 9 over 27 is equal to x over 100. So I'm going to cross multiply again. 27x is equal to 900. Divide both sides by 27. And I get a big long decimal, but I'm going to go ahead and shorten it to 33.3. Don't forget, we're looking for a percent here, so make sure that you put your percent sign afterwards. Okay, I'm actually considering not even showing you these solution pages anymore. I don't know what happened here. Alright, so again, is over of equals percent over 100. So what number is? There's my is. There's my percent. There's my of. So x over 80 is equal to 45 over 100. I'm going to cross multiply. And then you have 80 times 45, which is 3,600. Divide by 100. So x is equal to 36. Okay, would you look at that? There it is. Okay, again, is over of equals percent over 100. Here's my percent. Of 25 is my of. Is what number is my is? So that's an x where the is. Again, cross multiply 100 times x, 100x. 25 times 125 is 3,125. I'm going to divide both sides by 100. X is equal to 31.25. I seem to be on a roll here. Okay, with this problem right here, I want you to notice that there's a dollar sign in the problem. So that means you need to probably consider that your answer is also going to need a dollar sign. So here's my percent of what number is my of. This is my is. So I've got $1.56 over x is equal to 6.5 over 100. So I'm going to cross multiply. I get 6.5x is equal to 156. Divide both sides by 6.5. So I get 156 divided by 6.5 is 24. And again, because we have a dollar sign in our problem, we need to consider that there is a dollar sign in this answer. Okay, on this one we're looking for the percent. So what percent, there's my percent, of 72, there's my of, is 9, there's my is. So I've got 9 over 72 is equal to x over 100. So cross multiply, I get 72x is equal to 900. Divide both sides by 72. And I get that x is equal to 12.5. But wait, I'm not done. I was looking for a percent, right? So you have to make sure that since you're looking for a percent, you have your percent sign afterwards. Make sure you do that.